Hi folks. Now that we've learned about the basic mole-mole ratio and how to do one-step problems, we need to look at how to do bigger problems, because usually we don't measure substances directly in moles. We usually measure the mass of a substance, and then we can convert that to moles, but we start with a mass measurement. So these are going to involve longer 2 or 3 step dimensional analysis problems. So in these 2 or 3 step problems, you're typically converting from grams or particles or moles of a substance to grams or particles or moles of a different substance. Each step in this problem is going to require a different conversion factor, and it's going to be important to use the correct conversion factor for each step. So if you're going between grams and moles of the same substance, then you need to know the molar mass. You need to calculate that using the periodic table to get the atomic masses and adding them up. So these are the conversion factors you use if you're going between grams and moles or moles and grams. We've looked at this conversion factor before. Hopefully this is just a reminder. If you're going between particles and moles of the same substance, you need to use Avogadro's number. You need to use 6.022 times 10 to the 23rd. Again, we've used this conversion factor before. This is hopefully just a reminder, but there are 2 different versions of this conversion factor. You can either have Avogadro's number up top or you can have Avogadro's number down below. If you're swapping between moles and moles of different substances, that is when you need to use that mole-mole ratio that we learned about in the previous lesson. You're using the coefficients from the balanced chemical equation to convert from one substance to another substance. You always have your moles of the known in the denominator and moles of your unknown in the numerator. This is the core step in all stoichiometry problems, which is why I spent a whole different video on that one step. Now we're looking at how to convert how to use all 3 of these steps in one problem. We've done separate problems with all of these before. Now we're looking at putting them all together. Okay. When we first learned about the mole and how to convert between moles and particles, or moles and mass, I gave you this chart, this kind of flow diagram showing you the conversion factors that you use for each of the 4 possible conversions. If you're going from mass to moles, you divide by molar mass and you multiply by moles. If you're going from moles to particles, you divide by moles and multiply by Avogadro's number. I'm going to take this diagram and I'm going to rearrange it. It's the exact same diagram, just in a different format. This still shows me that if I go from mass to moles, I divide by the molar mass and multiply by 1 mole. If I go from, I don't remember which example I did before. I think I did moles to particles. I divide by 1 mole and I multiply by Avogadro's number. All right. The next thing I'm going to show you is I'm going to add a different substance. I'm basically going to do a mirror image of this same picture. Mirror image. This is the same, these are the same conversion factors as before. Whatever multiplication, whatever dimensional analysis you can do to substance A, you can do the same thing to substance B. What I'm going to add to this now is that mole-mole conversion factor, that mole ratio that lets us convert from one substance to another. This mole-mole ratio lets us bridge from substance A to substance B, where we can actually convert from substance A to substance B using this ratio. Remember, this mole-mole ratio comes from the balanced equation, those coefficients from the balanced equation. So you don't get to use this flow chart on a test, but I like to present it in class as an overview and for when you're first starting in on these calculations to help you see how many steps you're going to need, how many conversion factors you need, and what those conversion factors are. So, how do you know how many steps are needed for your problem? The first question you need to ask yourself is, are your known units in moles? Because if they're not, it's going to take you one step just to convert to moles to start the whole process. Moles of known to moles of your unknown, switching from one substance to another, always takes one conversion factor. And then, if your unknown units aren't in moles, then converting from moles to whatever units you're trying to get to is going to take another conversion factor, another step. So by asking yourself these three questions, you can determine how many steps, how many conversion factors your problem needs. The stoichiometry flowchart may help because if you label your known value as the starting point and your unknown value as the ending point, then you just count the number of arrows that you need to get from your start point to your end point. Again, you don't get to use the flowchart on the test, but using it for when you're first learning these kinds of problems may help you just remember what kind of questions you need to ask yourself. So let's try it for this problem. How many grams of sodium chloride will be formed from 1.25 moles of chlorine gas? Here's our balanced chemical equation. Step 1 for stoichiometry, always have a balanced equation. And we have to determine what our known and our unknown values are. My known is that I have 1.25 moles of chlorine gas, and I'm trying to find out how many grams of sodium chloride I can make. Okay, I'm going from moles of one substance to grams of another substance. So if I ask myself those three questions, is my known in moles? Yes, it is. So I don't need a conversion factor for that step. Am I converting between one substance and another substance? Yes, I am. That's going to take one step. Do I, is my unknown in units of moles? No, it's not. My unknown is in units of grams. So converting from moles to grams is going to take a step. So by looking at my known and unknown values, I can figure out how many steps this process is going to take. It's going to be a two-step process. So what are those two steps? Here again, we can look at our starting point and our ending point and count the arrows and see how many steps this takes. I'm given moles of a substance. So this is my starting point, and I'm trying to convert to grams of a different substance. So my ending point is the mass of a different substance. This is my ending point. And I want to see how many arrows does it take me to get from my starting point to my ending point. It takes 1, 2. And those are the two conversion factors I need. The first conversion factor I need is a mole-mole ratio. And the second conversion factor I need involves molar mass, converting between moles and molar mass. So going back to our problem, I'm going to leave space for two conversion factors. My first conversion factor, I want to switch from my known moles of my known substance to moles of my unknown substance. So here is my mole-mole conversion factor, and those moles of chlorine cancel out. I'm left with moles of sodium chloride, but that's not what I want in my final answer. I want to convert from moles of sodium chloride to grams of sodium chloride. So my moles are going to go on the bottom and grams are going to go up top. And I've already done the calculation that lets me know what the molar mass of sodium chloride is. 58.44 is the molar mass. My units cancel out appropriately, and now I'm just left to do the math. 1.25 times 2 times 58.44 divided by 1 and divided by 1. And this gives me an answer to 3 sig figs of 146 grams of sodium chloride. 3 sig figs because my initial value had 3 sig figs. Let's try another example. How many moles of mercury 2 oxide are needed to produce 125 grams of oxygen? Here's the balanced equation for the reaction. Let's label our known and our unknown. We know how many grams of oxygen we have. That's not moles. Grams are not moles. So it's going to take me one conversion factor to convert this from grams to moles. It's going to take another conversion factor to go from moles of one substance to moles of another substance. But then once I'm here, my unknown is written in moles. The units are moles. So I don't have to have another step. This is going to be another two-step process. Starting with 125 grams of oxygen, ending with moles of mercury 2 oxide. Again, let's look at where I'm starting. I'm starting here with grams of oxygen, and I'm ending here with moles of a different substance, mercury 2 oxide. Therefore, this is going to be a one-step, two-step process. I'll leave space for two conversion factors. I'm going to convert from grams of oxygen to moles of oxygen. The molar mass of a diatomic oxygen molecule is 32 grams for 1 mole. And now I need to convert from moles of oxygen to moles of my mercury 2 oxide. I'm just going to use the mole-mole ratio from the balanced equation. 1 mole of oxygen gas corresponds to 2 moles of mercury 2 oxide. Now I just need to do the math. Oh, after I make sure my units cancel. Now I just need to do the math. 125 times 1 times 2 divided by 32, also divided by 1. And you should get 7.81 as your final answer here.